Part C asks, we learned that the marginal rate of substitution measures the slope of an indifference curve, and it can be interpreted as the rate of change, as the rate at which a consumer is just willing to substitute a small amount of good 2, dx2, for good 1, dx1, such that utility doesn't change, du is 0. Consider the total differential, du, is the partial with respect to x1 times dx1, plus the partial with respect to x2 times dx2. Remember, we talked about total differentials in the calculus prerequisites chapter. This approximates how much du will change given a small change in x1 and a small change in x2. Let du be 0 and solve for dx2 over dx1 to get the formula for the marginal rate of substitution. You should get that the MRS can be calculated by the negative of the partial derivative of u with respect to x1 divided by the partial derivative of u with respect to x2. So let's go for it. We're going to let du be 0. We want changes in x1 and x2 that lead to no change in utility. We're on the same indifference curve. So du will be 0, which will be equal to del u x1 x2 divided by del x1 times dx1 plus del u x1 x2 over del x2 times dx2. Now I'm just going to move this term over to this side by subtracting it. We're going to divide some things, and then we're going to be there. Because, again, we want to solve for dx2 divided by dx1. So I'm going to have, so moving this over to this side by subtraction, negative del u x1 x2 over del x1 times dx1 is del u x1 x2 over del x2 times dx2. Divide both sides by this term and by this term to get, on this side, dx2 over dx1, which is what we wanted here, is this term. I can probably just copy paste. So negative partial with respect to x1 divided by this term here, the partial of u with respect to x2. Shrink that a little bit. And that is our formula for the marginal rate of substitution. Okay, going on to part D. Part D, I say, use the formula you derived in part C to calculate the marginal rate of substitution for this utility function, x1 plus x2, and interpret the marginal rate of substitution. So let's use this. We know that the MRS is this. And we have this formula right here. Copy. So let's find the partial derivative with respect to x1 of this utility function. Well, it's just 1, and we treat x2 as a constant, so the derivative of constant is 0, so it's just 1. Negative 1 divided by, and what's the partial derivative with respect to x2? We lost the 2 here. That's also 1. So the marginal rate of substitution is negative 1, which fits our, we discussed that this leads to this perfect complement indifference curves, and that we know that the MRS is the slope of the indifference curve, and of course here it's just negative 1, so that makes sense. The interpretation of the MRS is that when we give up anywhere along the line, along this line, here, 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 we'd be willing to give up, we give up 1 of x1 to get 1 of x2. Right? We give up 1 of x1 to get 1 of x2. That's the marginal rate of substitution. Now let's do the same thing, change colors. Let's do the same thing for this new utility function.